All right, help me out now. Does anybody have any questions with 1 through 12? Or you just want to run through them? Let's go ahead and let's tell me about US. Number 1, someone tell me. US is equal to what? How much? 78? If you don't agree, let me know. And then UZ, 44. ZT, angle SUT. How much? 39? Yes. Number 4? Okay, so let's look at it. Again, it's a rectangle, right? So let's find SUT is this guy right here. RUS is this guy right here, right? So what shape is it? Yeah, they equal 9. It's no big deal. All right, you see it now. All right, number 5. What do we have for angle UTR? 60? 62 degrees. Yes. Yeah, let's do that. Thank you, buddy. UTR. So let me find it. UTR right here. And then what else? SRT. Thank you. SRT. Now those two are what? Equal. You with me? Everybody good on that? Any questions now? Reed, you good? All right, let's try number 6. What did we say RSU was? Anybody have any questions with that? Everybody's good? All right, here we go. Number 7, what's the answer? 53? Number 8? Number 9? 10? 11? And 12? So everybody agree that's, I think that's easy, right? All right, hopefully feel good about that. All right. Now, these are the ones sometimes that are troubling. Does anybody need me to spend time on 13, 14, or 15? Go ahead. Which one? Anybody? Which one? 14? Does anybody need me to do 13? Slopes? All right, so the distance formula, what are we trying to prove? We're trying to prove that the diagonals are what? Congruent. If the diagonals are congruent, it is a rectangle. Agreed? All right, so here we go. Let me see if I can add a page. All right, here we go. All right, tell me the coordinates real quick. -4, 5. 1, 2. -4, 5, you said? And -4, 5. 6, 0. 3, -6. 1, 2, 3, 4, 5, 6, 7. Does that look right?
Yeah.
Bless you, bless you. All right, so now all we're doing, right, is we are looking for the diagonal from here to here. And then we are trying to figure out if that's equal to this diagonal. You agree with me? All right, so now again, you can use the formula, but I'm always trying to show you guys easy, right? I'm just making a right triangle out of it. Trying to anyway. All right. So we're looking for the hypotenuse, or that distance is equal to. So what is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? And then 11 squared is 121. And then what's this one? So plus 49. So that's equal to the square root of 170, right? All right, now let's knock out this guy right here. So what is that? Is it 13 and 1?
Yeah, and it's 170.
Yeah, there we go, guys. So distance equals square root of 170. What are you thinking? Is that right? Tell me.
So why did you just like give the other side of the line as the right triangle? Is that what?
Right.
Yeah, because you're squaring.
Are you talking about this? No, that's not what you're talking.
Like the right triangle made by the hypotenuse.
Hypotenuse.
Oh, never mind.
You sure? All right. So you good with that? All right. So that's what they mean by distance. And then, of course, if you want to do slopes, let's just review that. You'd find the slope of this, find the slope of this, find the slope of this, find the slope of this. Two of them, opposites would be equal, and consecutive would be negative reciprocals. Right? Everybody agree that's simple? Okay, so that pretty much summarizes, I'm pretty happy. 6, 6, 4. All right, now let's take a look at 6, 5. Was there anything on 6, 5? I don't even remember what I told you to do, guys. So did we have to do 8, 9, 10, or 11? Nothing? All right. So what's the difference between a rhombus and a square? Square is what? Yeah, 90-degree angles. Rhombus and a square. Square is a special rhombus. Yes, sir.
And aren't like all the diagonals in a rhombus equal?
Now think about it. Remember, square, as soon as you start to tilt, one diagonal gets larger, right? And again, this is what I'm saying, everybody. I honestly, I tell everybody every year, I don't have all these rules memorized. If I wanted to figure out if the diagonals were equal, I would just draw the shape and create a proof that shows whether they're equal or not equal. All right. So again, the square has equal diagonals. The rectangle has equal diagonals. All right. So let's go ahead and let's just pick one of these and do it. All right. Let's check out 11. Those numbers are easier. All right. So let's go to 11. I want you to grab number 11. Let's see what it is. Yeah, we're adding 11. Paste it, and let's do it. Now this one is -10, so you got to be real careful. Two -4. -6, -8. What in the world? So I agree?
No.
Did I plot that right or did I make a mistake?
Yeah. I did -2.
No, what did I do?
You did
Oh, I did -2. -2, +6. -10, 2. Oh, yeah, yeah. 2, -4. Thank you. Yeah, plotting points. All right, so if anything, that looks like a what?
Wrong. It's not a right. It has to be a wrong.
Well, it doesn't look like a rhombus to me.
It's not like it's not
It looks like a rainbow.
slopes.
All right, let's figure out what the slopes are. All right, let's see if it's something special. So here I went up 1, 2, 3, 4 over how many? Oh, well, I can actually I can just go up 1 over 2. Does everybody agree the slope here is 1/2? Is that slope 1/2?
Yeah.
And then down here, it looks to me like 1, 2, 3, 4, 5, -5, right? Of course, I picked a bad one, right? Is it over 2? 1, 2, 3, 4, 5. Yeah, -5 over 2. So now guess what? It's not a parallelogram, right? Oh, what am I saying? Yeah, no, up 1 over 2. This is 1/2. 1, 2, 3, 4, 5. Yeah, so this is -5 over 2. Okay, so the best I can do is say it's a parallelogram. Now, I can clearly see that it's not a square or a rectangle. So I guess we're just going to have to measure out the sides just to be certain. So this is 4, and this would be 8 then, right? So that distance right there is square root of 64 plus 16, right? Which is what? 80. And then this from here to here, that's 4, 10. Does everybody agree that's the square root of 116, right? Yeah, so that was a bad one. So it's not a rhombus, it's not a rectangle, it's not a square, so it's just a parallelogram. All right, we're gonna do another one, sorry. Yeah, I know. So it's telling you it's a parallelogram. All right, so let's do number 10. Hopefully that'll be better. Let's do number 10. Four, -6. Is that what you guys got? I feel like I'm not plotting points right today.
Yeah, that's what I got too.
All right, thank you. Bless you. So now we know it just is going to probably be a rhombus, correct? And what's true about the diagonals of a rhombus? Yeah, they're perpendicular, correct? So to me, I feel like if it's a rhombus, I can draw the diagonals and find the slope of the diagonals, right? And they should be negative reciprocals. And if they are negative reciprocals, that makes it a what? Makes it a rhombus. You could certainly measure all four sides. Does everybody agree with that? All right, but I'm like the quick way. So let's calculate the slope. What's the slope of that is 3/4? The positive one is 3/4, right? And that slope is -4/3. Someone confirm that. Make sure everybody's doing that. All right, so therefore it has to be a what? It has to be a rhombus. Could it be a square? Well, no, but I'm saying just because if you didn't see the shape and we found that the diagonals were perpendicular, could it be a square? Yeah, because a square is a what? Square is a rhombus. All right, but a rhombus does not have to be a square. All right, does everybody agree that's simple, right? Simple, very easy. All right, so let's knock out now the next one. Let's look at 6-6 now, everybody. Okay, so let's talk about the trapezoid. All right, the trapezoid is a special quadrilateral because it has only one set of parallel sides. The other two sides are not parallel. So what does that mean? What's true about this angle right here and this angle right here? They equal 180. Now, this is a special trapezoid. What kind of trapezoid is this called? What is it? It's not. How can it be an equilateral?
It's got two sides.
Two sides are equal. That is true. So that's what makes it special. What's it called? Yay, finally. Isosceles trapezoid. The reason why it's called an isosceles trapezoid is because two sides are equal. It's not going to have four sides equal. All right. Two sides are equal. So because those two sides are equal, then this is referred to a base angle. That is what? That is 63 degrees. This is also a base angle. That's what? That is 117 degrees. All right. So this is these two base angles are the same. And believe it or not, these are called base angles also. Those are the same in an isosceles trapezoid. However, are R and S, are those considered base angles? No, just to make sure you guys, all right, those are not the base angles, correct? All right, easy, I told you, very simple. That's an isosceles trapezoid. All right, and remember, anytime you make an isosceles, or not an isosceles, but anytime you make a trapezoid, consecutive sides of the base angles are supplementary. All right, those have to add up to 180. All right, let's look at number 2. All right, again, this is an isosceles, so measure of angle M would just be what? 38 degrees, easy. All right, now let's talk about this. All right, this is called a kite. Why is that called a kite? Because it looks like the kite you fly over the weekend. Yes, right. For some of you, all right, that's the kite that you fly. For those of you guys who are taking geometry, you would say the definition of a kite is what? Opposite sides are equal. So you're talking about this side and this side are equal. Consecutive sides. There you go. consecutive sides are congruent. All right, consecutive sides are congruent. Now, if I were to draw this from here to here, what's true about the top triangle and the bottom triangle? Yeah, they're reflected. So that means that they are what? They are congruent. Now we can easily say they are congruent because side, side, side. That is correct. So now this diagonal right here does what to the two angles? It bisects. Now again, I always try to remind you, there's no way to remember all these rules. Just draw it for yourself. We said they are congruent, therefore these two angles have to be equal and these two angles have to be equal. So I agree with that. All right, that's how you can tell that the diagonal bisects those two angles. All right, now what we're going to do is we're going to draw this. This is also a diagonal. All right, so now just to try to show you something that you don't have to memorize everything. Are these two angles equal here? No, that is correct. They are not equal. They are not equal because the right triangle and the left triangle are not what? They're not equal. That's how you can tell. All right. But what's true about this angle here and this angle here? They're equal because that's an isosceles triangle. Does everybody agree with that? And then this angle right here is equal to this angle right here. Does everybody agree with that? Now, right here, bless you. What does it look like is true about those two diagonals? Yeah, they are perpendicular. All right, they are perpendicular. All right, so does that make that a rhombus?
No.
No. Why is this have a different, why is this a little bit different than what we said earlier about the rhombus? Not all the sides are equal, but a rhombus is a what? We've been studying parallelograms, correct? Now we're studying things that are what? Not parallelograms, but they are quadrilaterals. So this is a quadrilateral. It's not a parallelogram. All right. So again, I think there's a question on the test where if you show that the diagonals are perpendicular, it has to be a what? It has to be a parallelogram in order for you to classify it as a what? Rhombus. If it's not a parallelogram and the diagonals are perpendicular, then you can call it a what? You can call it a what? Special quadrilateral. Yes, this is a kite. All right, that's a kite. All right. So again, for me personally, there's so much information here. All right, draw yourself a kite and then use it to answer all the questions. All right, you don't have to try to remember everything. To me, it's easy to prove. The top triangle is congruent to the bottom triangle. The left triangle is not congruent to the right triangle. So there's a lot that can be said. All right, or a lot that can be figured out from that information. All right, so with that, I'm going to go back to this right here. And what's true about angle B and angle D? They're equal. Thank you very much. So if they're equal, what's the quickest way to figure out what the measure of angle B and D are? Yes, thank you very much. The angles of a quadrilateral add up to 360. So if you take 360 and subtract 106, and then you divide that by 2. All right. And you get what? So those both angles are 127 degrees. All right. Yes, that's the other thing I was just going to say. You can't, this is another way you could do it. Come over here and say this is 18, and then this would be 35. And then if you add 18, 35, and 127, you can see that's 180. Everybody okay with that? Easy, very easy. All right, and then actually, I think later on, if you do this, this could be 35, right? This is 90, and then you can figure out what that angle is by doing 90, 35, subtracting. Does everybody see that? Very simple, very simple. All right, so let's look at number 4. All right, so how do I figure out what RH is? Yes, exactly, because this is a right angle. That's a right angle. You have to remember that. Because it's a kite, the diagonals are perpendicular. So now we're going to do, all right, now I'm going to review with you radicals. All right, so 12 is 4 times 3. 20 is 4 times 5. Come on, guys, stay with me. So this has to be 4 times whatever, the square root of 9 plus 25, 34. All right, please, I want everybody to understand that, so everybody look up. All right. You could do 20 squared plus 12 squared equals c squared. Does everybody agree with that? Well, there's a much quicker way. I noticed there was a factor of what? 4. So this is 4 times 5. This is 4 times 3. So this over here is going to be 4 times the square root of 5 squared plus 3 squared. What's 5 squared? What's 3 squared? 25 plus 9. 34. That's how people can do this mentally. All right? That's what I want you guys to be able to do. Can I break down 34? No, because it's 2 times 17. There's no perfect square in there. All right, now, let's say you didn't do that. 20 squared is 400. 12 squared is 144. 400 plus 144 is 544. And now you have to break down 544, which is obviously 16 times 34, but some people don't know that. All right, so that's where I got 4 radical 34. Now, how did I know that was 16 times 34, Harris? How did I know that was 16 times 34? No.
You have a big brain.
No. Small.
Yeah, no.
What? How did I know that?
Oh, well, because you knew there was 16 times.
Because I knew what the answer was.
Oh.
So 4 squared is 16.
Are you denying that you have a big brain?
I have no idea what that was. All right. Here we go. Let's move on. All right. Now, trapezoid. So T and S are midpoints. So this mark is congruent and this is congruent. So this line right here is technically called a mid-segment. If that is a mid-segment, if I said this was 10 and this was 20, what is TS? Someone who's brilliant. Who said 15?
15.
Why would you say that? I said someone who's brilliant. Yes, of course he's correct. He's allowed to speak. He's brilliant. Thank you, Davis. All right, here we go. How did you know that was 15? Sam. 30 divided by 2 is 15. Thank you. But how did I know that was the mid-segment? It's in the middle, right? It's in the middle of 10 and 20. What's in the middle of 10 and 20? Yes. Like I said, I don't understand the confusion here, but there's lots of confusion on this. All right, so let's try to figure this out. Since we just learned about the mid-segment, let me erase that. All right, now it says if HJ is 14 and LK is 42. What?
28.
Is it 28?
Yes.
What are some? That's what I'm saying. What are you guys doing?
I said it's 35.
You,
Maybe I'm wrong.
maybe you're wrong. That's a hard thing to admit. I agree. All right. But if you take 14 plus 42, I think that is,
56.
and then divide that by 2. We are at 28. Wow. Stop. Hey, just get out your calculators, okay? This is ridiculous. You used a calculator and you got 35. Wow. Time for a new calculator. Time for a new calculator. All right, so here we go. That one's 28. That was a joke, guys. If you can't add 14 and 42 without a calculator, we're in a little bit of trouble. I see you guys taking out your calculators. That's embarrassing. Okay, LK is 19. Uh-oh, this throws everybody off. You sure?
It's 11.
Yeah, some of you with negative 11. That's good.
It's -4.
All right. So obviously the easy way is to say I went down how many units? So I had to go down another 4. That's how simple these are. All right. Let's try. Wait a minute now. You got your calculator out now. You can do the math. That's good. HJ is 7. TS is 10.
13.
Bo. What'd you get, Bo? 13. Okay. We got a right answer from Bo today. 13. All right, let's go to the next one.
13.
Whoa, 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 whoa. KL is 17. JH is 9.
I said it first. No, I said back.
I got 12.5. Oh, no, it's 26.
13. Thank you.
Like a wild bunch of turkeys.
All right, don't worry about it. We got Harris on the right track today, so we're all good. I know things are going well. All right. Here we go. Verify that this is a trapezoid. All right, and then we're going to explain that it's an isosceles or not. So here we go. Let's go ahead and knock this out.
Yes.
Here we go.
Because
It
5
says
minus
verified.
1 is 4, and then 0 minus 3.
Sam, what are you saying?
So
What if
it's
it's
like
not a trapezoid?
5
Oh, it
minus
is. Oh,
1
here.
is 4, and then 0 minus 3 is -3, so it's 4
I
negative
think
3.
it's isosceles.
And then the other one is -12.
Sam, stop talking.
Sam, stop.
Yeah, thank you, Sam. You're correct.
Sam, please.
That just took-
I have no idea what he was saying. All right, here we go. Plot those points real quick, guys, and draw the shape. Let's see what's going on. 1, 3.
The answer is it's a trapezoid, but it's not isosceles. It looks a little bit like that. This is a weird looking trapezoid.
Wait, I think I got something wrong.
I got a line. Yeah, I got a straight line.
My trapezoid.
Was that what you guys got right there?
Yeah, it's not isosceles.
My trapezoid.
That's not what I. That is isosceles.
That's a scale.
It is a weird looking trapezoid. That's all.
No, but I'm asking you.
Yeah, that's what I
I don't know. It doesn't look isosceles to me unless I plotted it wrong. Is it? It's. I don't think it's isosceles. But here we still need to find this parallel, or we need to find those two slopes. So the top slope, what did we say it was? Is that -3/4? All right, and then 1, 2, 3, 1, 2, 3, 4. Yes. So the slope is -3/4 for both of those. Now, clearly,
Does that mean wait,
what we're gonna, what?
how would you say if the other two sides are isosceles?
Well, what we're gonna do is, I'm gonna first, I mean, obviously the slopes are not the same because they're just not, right? So that is the definition of trapezoid. I mean, if you wanted to, we could just say, let's quickly say the slope is 1, 2, 3, 4, 5. Is that negative 5/3? And then over here, it's 1, 1, 2, 3, 4, 5. The slope is negative 1/5. All right, so from that, we can say that it is a trapezoid. Then we're going to find this distance here. So that's the square root of what? Which is square root of 26. Anybody agree with that? Now remember, you're responsible now for drawing this out now, and then telling me that's the square root of 26. All right, because again, we're practicing, for some of you guys who are going to private schools, we're practicing reviewing distance formula, slope, and also that you know how to handle square roots. All right, all that's being tested. All right, so now what's the length of this side? Somebody said square root of 34, right? Anybody have any issues with that? So we would say definitely it is a, yes, it is a trapezoid, but it's not what? Isosceles. Go. The square root of 34? The what? Oh, yeah, yeah. So what I did was, remember, I just make this a right triangle. So from there to there. So this is 5 and this is 3. All right. Now, again, it's just a squared plus b squared equals c squared. And then the same thing with this guy over here. This was 1 and this was 5. Yeah, if it came out to be square root of 34 and square root of 34, then it would be an isosceles. You agree with that? Anybody have any issues? My homeschool peeps, you guys got any questions?
Nope.
All right. So here we go. Let's look at this last page. All right, let's get this done. All right. So here we go. Measure of angle T is what? 60 degrees. Number 2, Y. 112. Now remember, you have to tell me it's 112, right? Some of you guys are just writing down 112. Understand what I'm saying, right? It's not doing any good. You got to make sure you know why it's 112. Don't just write it in there. All right, so now I have to figure out what angle Q was. Anybody else think it's 101? That's what I heard. I'm not saying that's correct because I didn't do it. Everyone's telling me it's 101. That's what I want.
Yeah, I got 101.
101, 101. All right, I believe you then. All right, so now BC. Yep, that's right. Square root of 49 plus 16.
You can do 7 on the outside. Square root of
No. Square root of 65. Now listen, there is no common factor with 7 and 4, so there's no real shortcut to that. Is everybody with me on that? Like it was before. All right, if this was an 8, we could do it differently. All right, but there's no common factor with 4 and 7. So again, BC is the square root of 65. Any objections to that? All right, here we go. Number 5. So YV is called the midsegment. So if FE is 18 and YV is 28, then obviously CD is
38.
38. Yay, 38. Easy. All right, measure of angle F is 140. Measure of angle E is 125. What's the measure of angle D?
125.
What?
125 minus 55.
Yeah, I think it's 55 degrees. Everybody agree with that? Yes. Well, because, again, let's just review. All right, let's look at this. Because this is a trapezoid, I would want you to be able to tell me that this is equal to this, and this is equal to this. And I'd also want you to be able to tell me from this is equal to this. Does everybody agree? Now, remember, this is a trapezoid, so consecutive sides are supplementary. So E, this angle, the obtuse plus the acute equals 180, right? So again, if I just got rid of this right here, actually, you might be able to see it a little better. These two angles have to add up to 180. That's all. Easy as that. All right, let's see what this construction is. A set of stairs leading to the entrance of a building is designed in the shape of an isosceles trapezoid, with the longer base at the bottom of the stairs and the shorter base at the top. If the bottom of the stairs is 21 feet wide and the top is 14 feet wide, okay, I don't know why they do that, right? After all that, that's just a what? Mid-segment, correct? So what is it? Somebody said 17.5 feet. Everybody okay with that? I don't care about that one. All right. Oh, wow. Is that it? I don't care about the graphs anymore. Well, we didn't do any of this. All right, let's knock this out real quick, just to make sure. And then we won't have any homework. And then I'll post the review. And if you want to get started, you can. All right, so here we go. This is a rhombus. So let's figure out what's true. So RK is 5. RY is 13. Which means all sides are what? 13. And angle YRZ. Hold on one second. That's 67 degrees, right? All right. So who can tell me what KY is? Oh, no, definitely not. How much?
Oh, it's 8. Isn't it 5, 8, 13?
No, close.
5, 9.
Right, I know this is 12 without doing any work.
Oh, yeah, because that thing.
Because those triples.
Yeah.
All right, remember, 3, 4, 5, write this down. 5, 12, 13, 8, 15, 17, 7, 24, 25. Those are common on all standardized tests. So how did I know it was 12? Well, first of all, it's a rhombus, so the diagonals are what? Perpendicular. Does everybody agree? So that makes it a right triangle. So 13 is the hypotenuse. One of the legs was 5. That means the other leg had to be what? Has to be 12. Does everybody agree? Yes.
So, I was in like, you have 5, and then you have 13, but 13 is the C. How
Yes.
did you get the B if you had that A and the C?
We do 169 minus 25, which is 144. Square root of 144 is 12. Do you agree with that or not? You sure? Right? Weren't you asking me about solving a squared plus b squared equals c squared, right? So it's 5 squared plus b squared equals 13 squared. 25 plus b squared equals 169. B squared equals 144. So b was 12. Right? Is that what you're asking me, right? So if you don't know the triples, that's how you do it. Yes, sir. Of course, I don't care.
How do you do it, or how do you know that it is the one?
Well, it could be A, right? A, remember, A and B don't matter. It's C that matters.
How do you know that the fifth is C?
Well, because it's opposite the right angle, right?
Okay.
This is the right angle, true? And C is always opposite the right angle. All right, good review. All right. So let's just, I always tell kids, I think it's easier just to go ahead and mark everything. If that's 67, then this angle right here is going to be what? 23, right? Everybody agree with that? Now, is the top triangle the same as the bottom triangle? Right? So this angle right here, I just want to make sure you guys know, this angle right here has to be how many degrees? 67, right? Now, this is what I'm trying to tell you. These are all the rules that are going to be so hard if you're not, I don't want you to know the rule. I want you to be able to tell me the top triangle is equal to the bottom triangle. Is that true? If the top triangle is the same as the bottom triangle, to me, this then is easy to say this angle is 67. Is everybody understanding what I'm saying? Right? Because again, I know for certain after teaching this for so long, people do really well on this chapter, they do really poorly. And I always tell kids, obviously, to me, it's easy. All right. And I think some kids who try to just remember all the rules, it's just not possible. Does everybody understand what I'm saying on that? Every single time I draw what's referred to as a rhombus, I recreate everything that's true about the rhombus. And then I answer the questions. Like I really didn't know, okay, those two, the diagonal of a rhombus bisects the angle. I didn't say that. I draw the rhombus and I prove to myself, okay, the diagonal of the rhombus bisects because the top triangle is equal to the what? The bottom triangle. Therefore, those angles are equal. Is everybody with me? Now, the top triangle is also considered isosceles. Does everybody agree with that? So that means this over here has to be what? 67, which means this over here is what? 67. All right? Which means this angle right here has to be 23, and this is 23 and 23. That's what I'm trying to show you. That's what I mean about trying to remember all of the rules. There are so many rules for each shape, all right? It's just not possible to try to remember all of the rules. So if you just draw the shape, you are good enough to be able to tell me if the top triangle is equal to the bottom triangle. All right. Now, what's true about all four of those squares or all four of those triangles that are cut? That didn't come out very right. So let's do what's true about this triangle, this triangle, this triangle, and this triangle. They're all what? They're all equal. All right. They're all equal. And that's easy to prove. All right. So with that in mind, let's answer the questions now. What's KY? 12. What is PK? Good. What's YKZ? What's PZR? How much? Yeah. Right. So again, I like to just write all the answers down instead of trying to find each one individually. I think that's easier. All right. Last one. 5, 6, 7, 8. Bless you, bless you, bless you. All right. So if it's a rhombus, PQ is 3 radical 2, which means all of them are 3 radical 2. And AP is 3. All right. So now what I want to do is, because it's a rhombus, do we all agree this is a right angle, right? Okay, so now I want to find out what this side is. All right. So now a squared plus b squared equals c squared. So this is where you got to listen. All right. A squared plus b squared equals c squared. What is c? 3 radical 2. So if I square that, everybody should be able to tell me that's obviously what? What is 3 radical 2 squared? Thank you. Go. Obviously 18, right? Now again, I'm telling you, this is what you're going to need to know. 3 squared is what? Square root of 2 squared is 9 times 2. All right, I'm happy. And then b squared is what? 9, right? Plus a squared. So then a squared equals what? 9. So a has to equal what? 3. Wow. So this right here is 3. That makes that 3. That makes that 3. Does everybody agree? So that rhombus is actually a what? Square. How do I know for sure it's a square? The diagonals are equal. If the diagonals are equal in a rhombus, then it is a square. All right, which means all of these are 3s. What's the measure of this angle right here, guys? 45. That's what? All of them are what? Yay, okay, that makes good sense. So AQ, somebody tell me. 3. APQ, 45. Angle MNP,
90.
90.
good, thank you. And PM,
6.
6.
yay, right. Does everybody agree? That's not hard. All right, so listen, honestly, if there's any doubt in your mind, you should just scroll through 6.4, scroll through 6.5, scroll through 6.6, and just make sure you have a general understanding of everything that we talked about. All right, that was kind of quick. 3 sections in 2 days. All right, but our test is Friday, so I'll have a review for you tomorrow. All right. Thank you, guys. Good job for today, my homeschool peeps. Hopefully that worked out. All right. No homework unless you just want to review that stuff. All right. You guys have a great day, okay?
You too.
Thank you. Bye.
Take care, guys.